Good day everyone. The topic that we'll be going to discuss is all about clustering or cluster analysis. It is a machine learning technique which groups the unlabeled dataset. It can be defined as a way of grouping the data points into different clusters consisting of similar data points. The objects with the possible similarities remain in a group that has less or no similarities with another group. It does it by finding some similar patterns in the unlabeled data set, such as shape, size, color, behavior, and etc., and divides them as per the presence and absence of those similar patterns. The clustering analysis is an unsupervised learning method. Hence, no supervision is provided to the algorithm, and it deals with the unlabeled data set. If the data set is not labeled, there are so many questions that we are trying to ask. Like for example, how is the model learning? How is it evaluating itself to understand? How well is performing? Well, first let's go ahead and touch on the fact that with unsupervised learning, since the model is unaware of the labels for the training data, there's no way for it to measure its accuracy. So accuracy is not a metric with unsupervised learning. Now, essentially, with unsupervised learning, the model is going to be given the unlabeled data set, and it's going to be attempt to learn some type of structure from the data and will extract the useful information or features from it. It's going to be learning how to create a mapping from given inputs to particular outputs based on what it's learning about the structure of this data without any labels. So let's make this idea solid with another example. One of the most popular applications of unsupervised learning is through the use of clustering algorithms. Let's say that we have the height and weight data for a particular age group of males and females. But this time we don't have the labels for this data. So any given sample from this data would just be a tuple, consistent at one person's height and weight. But there would be no associated label telling us whether this person was a male or female. Now, a clustering algorithm could analyze this data and start to learn the structure of it even though it's not labeled. Through learning the structure, it can start to cluster the data into groups. Then we could imagine that if we were to plot this height and weight, then the data on a chart that maybe it looks something like this. So this weight is on x-axis and height is on the y-axis. Now there's nothing explicitly telling us that here are the labels for this data, but we can see that there are pretty distinct clusters here, and so we could infer that perhaps as clustering is occurring based on whether those individuals are male or female. So one of these clusters may be made up by predominantly of females, while the other is predominantly male. So clustering is one of that makes use of unsupervised clustering. After applying this clustering technique, each cluster or group is provided with a cluster ID. Machine learning systems can use this ID to simplify the processing of large and complex datasets. The clustering technique is commonly used for statistical data analysis. Note, the clustering is somewhere similar to the classification algorithm, but the difference is the type of the data set that we are using. In classification, we work with the labeled data set, whereas in clustering, we work with the unlabeled data set. The clustering technique can be widely used in various tasks. Some most common uses of this technique are the market segmentation, statistical data analysis, social network analysis, image segmentation, anomaly detection, and etc. Like for example, I have only one example here in market segmentation. So just like some people may want to buy ketchup that's a little sweeter, a little spicier, produced by a particular brand, and so on. So from the few key features of the product, such as the price, quality, and brand name, we can create groups of people into three, and like for example, they care about the same things and base their buying decisions On the same factors, maybe we find that in segment A, with price-sensitive features and buys primarily on price, and segment B, we'll call them the tasters, by primarily in taste, and in segment C, the organizers who only buy ketchup made from organic ingredients. We could dig deeper and develop a more fine-grained modes of ketchup preferences. For example, exactly how price is segment A, and what flavors really make a difference to segment B, and how much more segment C willing to pay for organic ingredients. So that must be the problem to identify. So clustering is so much important in this various task in order to solve the problem. Apart from this general usages, it is used by Amazon in its recommendation system to provide recommendations as per the past search of products, as well as the Netflix also uses this technique to recommend movies and web series to its users as per as the watch history. There are types of clustering methods. The clustering methods are broadly divided into hard clustering. Data point belongs to only one group, and sub-clustering, also data points that can belong to another group. But there are also other various approaches of clustering exist. Below are the main clustering methods used in machine learning: the partitioning clustering, density-based, distribution model-based, hierarchical, and fuzzy clustering. First, let's talk about the partitioning clustering. It is a type of clustering that divides the data into the non-hierarchical groups. It is also known as the central-based method. The most common example of partitioning clustering is the k-means clustering algorithm. So in this type, the dataset is divided into a set of k groups, where k is used to define the number of predefined groups. The cluster center is created in such a way that the distance between the data points of one cluster is minimum as compared to another cluster's centroid. And then the density-based clustering. This method connects the highly dense areas into clusters, and the arbitrarily shaped distributions are formed as long as the dense region can be connected. This algorithm does it by identifying different clusters in the dataset and connects the areas of high densities into clusters. The dense areas in the data space are divided from each other by sparser areas. So these algorithms can face difficulty in clustering the data points if the dataset has varying densities and high dimensions. Based on the idea that a cluster and a data space is a contiguous region of high point density separated from other cluster by contiguous regions of low point density, then the data points in the separating regions of low point density are typically considered noise and or outliers. Okay, so the distribution model based clustering. This method, it is the data that is divided based on the probability of how a dataset belongs to a particular distribution. The grouping is done by assuming some distributions, commonly Gaussian distribution. An example of this type is the expectation maximization clustering algorithm that uses Gaussian mixtures models, or the GMM. So, based on the figure, the distribution-based algorithm clusters data into three Gaussian distributions. As distance from the distribution center increases, the probability that a point belongs to the distribution decreases. The bands show that decrease in probability. When you do not know the type of distribution in your data, then you should use a different type of algorithm. Okay, so next is the hierarchical clustering. This can be used as an alternative for partition clustering, as there is no requirement of pre-specifying the number of clusters to be created. In this technique, the dataset is divided into clusters to create a tree-like structure, which is also called a dendrogram. The observation or any number of clusters can be selected by cutting the tree at the correct level. The most common example of this method is the agglomerative hierarchical algorithm. So in this figure, this is somewhat like they were using dendrograms, on which this is very useful in segmentation. The advantage of not having to predefine the number of clusters gives it quite an edge over k-means. However, it doesn't work well when we have a huge amount of data. The fuzzy clustering is a type of soft method in which a data object may belong to more than one group or cluster. Each dataset has a set of membership coefficients, which depend on the degree of membership to be in a cluster. The fuzzy C-means algorithm is an example of this type of clustering. It is sometimes also known as the fuzzy k-means algorithm. So fuzzy clustering provides more accurate and close to nature solutions for partitions, and herein implies more possibility of solutions for decision makings. So there are clustering algorithms. So this can be divided based on their models that are explained before. There are different types of clustering algorithms published, but only a few are commonly used. The clustering algorithm is based on the kind of data that we are using, such as some algorithms needs to guess the number of clusters in the given dataset, whereas some are required to find the minimum distance between the observation of the dataset. Number one is the k-means algorithm. This is one of the most popular clustering algorithms. It classifies the dataset by dividing the samples into different clusters of equal variances. The number of clusters must be specified in this algorithm. It is fast with fewer computation required with a linear complexity of problem. So in the figure or the output image, so it is clearly showing that the 5 different clusters with different colors. The clusters are formed between two parameters of the dataset: annual income of customer and spending. We can change the colors and labels as per the requirement if we have a choice. So in cluster 1, we clearly see that it shows the customers with the average salary and average spending. So we can categorize these customers as careful. In cluster 2, it shows the customer has a high income but low spending, so we can categorize them as careful. In cluster 3, it shows the low income and also low spending, so they can be categorized as sensible. In cluster 4, it shows the customers with the low income with very high spending, so they can be categorized as careless. In cluster 5, it clearly shows that the customers with high income and high spending, so this can be categorized as target, and these customers can be the most profitable customers for mall owners. Okay. Next is the mean shift algorithm. The mean shift algorithm tries to find the dense areas in the smooth density of data points. It is an example of a centroid-based model that works on updating the candidates for centroid to be the center of the points within a given region. So with the figure, the results in 3 kernel density estimation peaks and thus 3 clusters. So the figure uses a small kernel bandwidth and results in more than 3 clusters. As with all clustering problems, there is no correct clustering. Rather, correct is usually defined by what seems reasonable given the problem domain and application. Next is the DB-scan algorithm. This stands for density-based spatial clustering of applications with noise. It is an example of a density-based model similar to the mean shift, but with some remarkable advantages. In this algorithm, the areas of high density are separated by the areas of low density. Because of this, the clusters can be found in any arbitrary shape. So in the figure, the algorithm proceeds by arbitrarily picking up a point in the datasets until all points have been visited. If there are at least mean points within a radius to the point, when we consider all these points to be part of the same cluster, the clusters are then expanded by recursively repeating the neighborhood calculation for each neighboring point. The expectation maximization clustering using GMM. This algorithm can be used as an alternative for the k-means algorithm, or for those cases where the k-means can be failed. In GMM, it is assumed that the data points are Gaussian distributed. In a figure, an example of clustering of old faithful eruption data. The random initial model, which due to the different scales of the axis, it appears to be two very flat and wide spheres, is fit to the observed data. In the first iterations, the model changes substantially, but then converges to the two models of the serve. Okay, so number 5, the agglomerative hierarchical algorithm. It performs the bottom-up hierarchical clustering. In this, each data point is treated as a single cluster at the outset and then successively merged. The cluster hierarchy can be represented as a tree structure. In the figure, it is said that a dendrogram contains the memory of hierarchical clustering algorithm. So just by looking at the dendrogram, you can tell how the cluster is formed. We see that the distance between the data points represents the similarities, and that the height of the blocks represents the distance between the clusters. So you can observe from the above figure that initially P5 and P6, which are closest to each other by one or by any other point, are combined into one cluster, followed by P4 getting merged into the same cluster, C2. The P1 and P2 gets combined into one cluster, followed by P0 getting merged into the same cluster, C4. Now P3 gets merged in cluster C2, and finally both clusters get merged into one. Okay. Next is the affinity propagation. It is different from other clustering algorithms, as it does not require to specify the number of clusters. In this, each data point sends a message between the pair of data points until convergence. It has time complexity, which is the main drawback of this algorithm. So in the figure, it is a clustering when a subset has a very low preference. The data points can be seen as a network where all the data points send messages to all other points. The subject of these messages are the willingness of the points being exemplars. We also know that in clusters, there is only one exemplar. All the data points want to collectively determine which data points are exemplar to them. There are applications of clustering. In identification of cancer cells, the clustering algorithms are widely used for the identification of cancerous cells. It divides the cancerous and non-cancerous data sets into different groups. In search engines also work in the clustering technique. The search result appears based on the closest object to the search query. It does it by grouping similar data objects in one group that is far from the other dissimilar objects. The accurate result of a query depends on the quality of the clustering algorithm used. Customer segmentation. It is used in market research to segment the customers based on their choice and preferences. In biology, it is used in the biology stream to classify different species of plants and animals using the image recognition technique. In land use, the clustering technique is used in identifying the area of similar land used in GIS database. This can be very useful to find that for what purpose the particular land should be used, and that means for which purpose it is more suitable. And that's it. Thank you for listening.